Hello everybody, welcome to Unit 1 of Grade 9 Math. Starting with number sets. So, what are number sets? You may be looking at these symbols thinking, what the hell are these? Well, let me break it down for you. N are natural numbers. Now, what does that mean? Natural numbers are positive whole numbers used for counting. It sometimes includes 0, but people argue about it. So some examples would be 1, 2, 3, 4, 5, etc. all the way to 100. Anything just counting upwards. Just remember natural numbers are positive. So -1 would not be a natural number. Let's move on to this Z looking thing. What is this? It represents integers. I misspelled that. That is a G. Integers are all whole numbers including positive, negative, and 0. So it could be -1, 0, 1, 2, etc. Any positive or negative whole number is an integer. Q, or the Q with the weird dash on top. The Q without the dash are rational numbers. What are rational numbers? Rational numbers are numbers that can be written as a fraction, where this and this, the one on the bottom, cannot be 0. You cannot have 0 in the denominator. It also includes terminating and repeating decimals. For example, let's just give a couple of numbers here. 1 over 2 is a rational number. Negative 1 over 2 is a rational number. 0.5 is a rational number. 0.3333, etc. Keep going, is a rational number. And 5, just the whole number, could also be a rational number. I need to make space for the Q thing. Okay, let's move the Q thing down here. What does this mean? This is irrational numbers. What are irrational numbers? Irrational numbers are numbers that cannot be expressed as a simple fraction. Their decimal forms are non-repeating and non-terminating. For example, √2, √3, pi, and e. Don't worry about this e. It's an imaginary number, and you will not see this until grade 12. Basically, if the decimals are random, 3, 4, 5, 6, and are not repeating like this one, it's an irrational number. And how is √2 an irrational number, you may ask? Well, if you do the √2, you would get 1.41421, etc. As you can see, this is not terminating or repeating. Terminating as in it stops right away, like this one over here. And yeah. Now let's get into this bad boy, the R. What does this R represent? Well, the R is real numbers. What are real numbers? Real numbers are a set of all rational and irrational numbers combined, any point on a continuous number line. So it can be literally anything. So a rational number, well, this shows it perfectly. A rational number is everything inside of this box, in the circle. So natural numbers, integers, rational numbers, and irrational numbers. Real numbers are basically any one of these. And yeah, I was going to put some examples in here, but I kind of already did it here, but I'll just do it anyways. So for here, we can do 1, 2, 3, -1, 0, 1. Q, or rational numbers, we can do 1 over 2, 0.33. Real numbers, let's just give it an I, a E, or let's say √3. Irrational numbers, oh, well, we can also give it that, so let's give that pi. Real numbers, 1, 2, 1 over 2, it can be anything, so yeah. And that about sums it up for number sets. Okay, let's take one more look at number sets before I erase it. Okay, got it? Great. Okay. Now, let's move on to our next section, which is number sets, or you can call it set notation. So what are set notations? Set notations are a standardized mathematical language used to describe a collection of objects, usually numbers, without having to write out super long sentences. So instead of saying all whole numbers between 1 and 5, mathematicians, the smarty pantses, use set notation to write it concisely. So how do we do it? For example, when a set contains, let's say, 2, 4, 6, and 8, we can write it as 2, 4, 6, and 8 with this weird bracket thing here. As you can see, this tells us that this set contains these numbers without having to word it out, the whole thing. There are a couple of symbols that you will encounter while dealing with this. So the first one is this E, this backwards E looking thing. I mean, yeah, this is called, or it means, is an element of. For example, 3 is an element of 3 is an element of the set of integers. Z, this symbol being integers. And yeah. So next symbol, which is the opposite, is not an element of. So we can say 0.5 is not an element of integers because 0.5 is not an integer. It is a rational number. Next symbol is this, just a line, or these colons. This means such that. What does this mean? Let's use this as an example. X what does this mean? The set of all x such that x is greater than 0. So it can be any x, but x must be greater than 0. That's what it means basically. And this, or an empty set like this, just means that a set contains no elements. Okay, now that the meaning and examples are out of the way, let's go into these practice questions. So how would we solve this one? X equals 3. The set notation would just be 3, because there's only a 3. X plus 5 equals 9. First, let's solve this. X plus 5 equals 9 minus 5, cross this out. X equals 4. So the set notation for this is 4. Next, x squared equals 16. So we can solve x using square root. So square root, oh, oops, I lied. Equals 16. Yeah, let's square root this so we can get rid of this. Square root of 16 is plus minus 4. So the set notation would be 4, negative 4. Oh, wrong bracket. There we go. Negative 2 to 8 inclusive. So let's assume that it's real numbers. So x is an element of any real number, but x is less or equal to negative 2, but less or equal to 8. Oh, sorry, that's bad wording. X is greater or equal to negative 2, but less or equal to 8. Now, what does this mean? X is an element of natural numbers. So x can be any natural number except for 0, because x here is greater than 0. So we can put the set notation as just 1, 2, 3, 4, 5. That was like that. And here, x is an element of integers. So the numbers have to be greater or equal to negative 4, but less than or equal to 2. So this set would be negative 4, negative 3, negative 2, negative 1, 0, 1, 2. And this satisfies this statement. Now here, x is an element of, or can be, any natural number, but x is greater than or equal to 5. So we can set this up with a weird bracket. Since we have this sign, meaning greater or equal to, it can also equal 5, so we can start it with 5, 6, 7, 8, 9, and so on. This one, x is an element of integer, so it can be any integer, but x must be greater than negative 2 and less than 2. Since there's no line under it, that means it cannot be equal to that, which means when we do our set notation, we'll skip negative 2, go straight to negative 1, 0, and 1, because it cannot be 2 either. And finally, x can be any real number, any integer, but this line means but, basically. X must be greater, oh, never mind, x is less than -4, but greater than or equal to -1. So what does this mean? It means that this is empty. Why, you may ask? Well, no number can be strictly less than -4 while simultaneously being greater or equal to -1. So that's why it cannot be anything, and that's why we leave it empty. Well, that about sums it up for this first lesson of grade 9 unit 1, which are common number sets as well as set notations. I hope you guys learned something, and if you have any questions, don't be afraid to leave it down in the comments. I'll be sure to answer any questions you may have. Anyways, have a great day, everyone, and I'll see you guys in the next lesson.